Welcome to Taking VR to 11, Best Practices for Next Level VR Experiences.
All right, hello everybody. We're from Unity. My name is Brad.
I'm Andy.
And we work in Unity doing kind of bleeding edge experiments with AR and VR or any cutting edge technology really. And our job is to kind of discover the problems and the possibilities in new technology and kind of dog food that before you have to. So everything we're going to talk about today is from personal experience. We're kind of constantly trying to do stuff that no one else has ever done. So our goal is to prevent some of the battle scars that we've got in the last couple of years.
Yeah, so we're going to go over some guiding principles first of how to really get VR to look nice, and then go over more specifics in categories like graphics, audio, and interaction.
So if we're going to talk about next level or high-end VR, I guess we better give our definition of it.
So first off, there's a good chance you're going to have to leave the min-spec crowd behind, and that's talking about like the 290 and the 970 crowds.
You can always invest extra effort into different graphic settings and stuff, and Unity kind of provides the, the functionality to do that relatively easy. But it's not going to be quite the same unless you shoot straight for a hardware target that you want.
The information we're presenting is targeting the PBR pipeline, which is Unity's modern graphics. It's physically based rendering. It's just designed to simulate what graphics look like in the real world.
So yeah, speaking of this, I don't know if any of you have seen the Atom demo yet, but our goal is to push VR to the point where we can actually render this kind of thing in real time in your HMD. So VR developers kind of encounter a lot of rules all the time, essentially do's and don'ts. But VR is really young, and none of this is really set in stone. So make sure that before you accept a rule, you understand why it was made. Challenging a rule has a cost in time, and that cost is really rarely apparent when you first set out. So trust in kind of the things that other developers have gone through has value here. And since you're probably going to ask or wondering anyway, it happens all the time, kind of the Oculus versus Rift thing. Oculus versus Vive. At Unity, we really try not to, pick favorites. It's cross-platform, so when it comes, it depends a lot on what kind of experience you're looking to make. So, get the information and make your own decision on what platform you'd like to target, or just go for both.
So if you find yourself in a new situation, which is very common in VR, and there is no how-to guide, we have basically 3 guiding principles that will help you engineer a solution.
So the first one, consistency. A lot of times when people are talking about something being immersion breaking, what they really mean is inconsistent. Things that are inconsistent, if you have a set of consistent reactions in a game, that'll be a system. Systems can be learned. People really, really like systems. Consistency is just really good for everything. Relationships too, you name it. And if something does not behave in the real world, like it is behaving in VR, as long as you have a consistent system set up, people accept it right away. People pick up systems faster in VR than they do in real reality. So we would ask that when you're considering your asset pipeline, your art pipeline, your design pipeline, everything, you're always considering this.
So VR is a simulation, and it's viewed through hardware, which is our biological bodies and the HMDs, and they both have limitations that give us kind of blind spots. So if we keep these limitations in mind, we can focus our effort where it needs to go without anything being wasted. In essence, there are roughly 2 additional levels of detail that VR has over traditional AAA graphics.
So a thing that's kind of important to keep in mind, it might be a point of research for another talk, is that not all depth information is communicated via stereoscopy. So that's you'll see that come up a lot more in the future. So it's not really enough in VR to say, okay, I'm going to make my assets as low poly as they can be. You really have to consider the limitations that you have in the design of your experience. You essentially want to minimize the variables. Iterating and pivoting later on when you're developing for high-end VR is really, really hard in an optimized environment. So you want to make sure you do tons and tons and tons of prototyping before you start, figure out what you want to do, and then kind of focus on that. A badly designed scene or an experience can be extremely hard to fix, so be preemptive, be constantly testing for things that are occluded. Yeah, I mean.
And one thing to note is that assets in basically the VR spaces that have to be really detailed and we have really high resolution textures, these strain more than just your GPU and your CPU. This is going to strain your version control, this is going to strain your iteration times, it's going to strain your editor. So make sure that those assets that you are going to view are actually going to be viewed up that close. In VR, generally, what we found is that you have one object that's really close to you and then a whole wide range of backgrounds that can be much less fidelity.
So here's just a quick example of a kind of a scene that's fairly quantized. You can see that if you're inside of that room in VR, there could be anything in that building. Who knows where that door goes? Who knows what's behind that wall? But here we can make sure that that occlusion is working because there's actually nothing outside of the walls. And we have a tight control on all of our lighting, reflections, and everything, so yeah.
So the problem with giving performance guidelines is that there are always edge cases, and the only way to be absolutely sure that you're getting the best performance is to be constantly testing and profiling. If it isn't working, you can try rebalancing, you can do optimization, smoke and mirrors, and reauthoring.
Oh, and I should also mention that smoke or mirrors is not advisable in VR at this point. It's insanely expensive.
So high resolution textures require a very large amount of detail. So for something like that, you'll want to be using a non-destructive material creation tool, something like Algorithmic Suite. Also, textures tend to be the biggest resources hog. That's the worst part about all the version control and the importing times. So any way you can get higher detail for less space, like detail maps or multiple materials, use that as much as possible. Usually the shader trade-off is worth space savings. Here we are up close and personal with a step ladder. It's a shiny surface, so now our players could actually get their heads that close. So all the metal detail had to be modeled out. Normal maps won't cut it here. Oh, much better.
Yeah, we're good. Yeah. So here's some geo.
Yeah, this is another asset we designed only to see in the intermediate range. A lot of the paint splats are just normal maps, even the gauge details, and from that distance it looks fine.
So when I say author with context, it's kind of, once again, kind of comes back to what we said about the ranges. User hands are a good example of something you can't really skimp on. People get in the idea that they're like, okay, everything needs to be minimum poly, but if you really watch people in VR, the very first thing that they do is they take their hands or whatever represents their hands in VR and they bring them up really close and go, oh wow, this kind of thing. And I'll still do it with every experience I get into if I start something that's got a gun and something like, okay. So you really want to make sure you kind of spot right away which assets to focus on.
And one note on level of detail, I personally recommend Simplygon. It's so much faster, it gets really high quality. We've had dedicated artists do this for us manually before, and they all swear by Simplygon.
And also, when it comes to things like using occlusion and LODs or batching, you really can't have an idea on this until you test it in VR. You could say, okay, the system is set up perfectly, ideally, everything should work, but there's a huge iterative process here of getting something in and saying, you could be in your asset creation tool and say, there's no way this is going to be high poly enough. You get it in VR, and odds are it might just work.
So here we have an ancient tablet carved out of stone. There's a high amount of geometry detail, but we don't go down to the rough rock surface. That's just normal maps. And even under close scrutiny, that's fine because it doesn't really change the silhouette of the object. And here we have a level of detail group for a dog character we created. Going from left to right, we have the lowest amount of detail to the highest. Notice as you get further and further back, the difference between the four really vanishes.
Yeah, these aren't just examples of how the levels of surprise a dog can have. So animation in VR is really, really difficult. Small imperfections that would be overlooked, even on a large screen, are glaring and super unnatural in VR. So you want to make sure that you're constantly iterating in VR. It's easy to get in this sort of mindset where we have an animator kind of working off in the corner, and he says he's going to have something ready by X day. We get it in at the end and slap it in. That'll almost never work. The smallest aspects, the smallest chunks of the animation, you want to get those into VR as soon as possible. There's tools being developed right now where you can start to view things in VR from 3D asset creation tools, and those will be great. But for now, have a steady pipe flowing.
And if you know your character quality isn't perfect, don't let them get too close to the player.
Yeah, so, well, also an important thing to mention is we actually kind of figured that with the production time increase and the bug fixing and everything like that, it'll take about 4 times longer doing things in this iterative process, but it's really worth it.
So here we have one of our animated characters. His face is covered and he's maintaining his distance. He's staying out of the uncanny valley. It's a simple walk-in interaction sequence. But remember that the user can be anywhere in this tracked area, so we have to use a solution to make sure that the animations account for that he's looking at us, that he doesn't walk through us. And note that even taking all these steps to stay out of the uncanny valley, it still took us a few months of iteration to get it right.
Yeah, make sure your animators have thick skin, because it's really obvious when a boot is even a couple of millimeters off the ground and you send it back and you're like, could you do it one more time? Yeah. So a lot of people have heard that frame rate is king, and it is, but for many experiences you don't actually need to maintain the frame rate of the hardware at all times. Really depends on what you're doing, but like we said before, only the Sith deal in absolutes.
Yeah, so if you're targeting basically a reprojection pipeline, just keep in mind that if you have any performance hiccups, you are going to be in a very bad place.
Mm-hmm. So Andrew's going to tell us a little bit about the graphics pipeline here, our basic rendering pipeline.
Yeah, so this is an extremely, extremely simplified view of a rendering pipeline. So per camera, you're going to set up lights, you're going to cast shadows, you're going to do all your main rendering, and then you'll apply image effects. And it says to screen, but really this happens per camera, and in VR it can happen per eye. Mm-hmm. Now there's optimization, so this becomes more of a web than a straight line.
We're not going to go any further in rendering than this, so don't get freaked out. It gets more interesting and sexy from here, I assure you. With a lot of the things we want to talk about, having some sort of basic intro to the pipeline is, I think, essential.
Now, the biggest bottlenecks you're going to find in here are lighting and shadows, which is tricky because they also add the biggest bang for your buck in VR, both visually and as a narrative tool. You can use it to draw attention, you can use it to ground objects. We're used to seeing light. It's one of the ways that we see stereo objects. So you really do need it.
And MSAA, that's key. John Carmack recently said that if it was up to him, he would block basically anything that was going on the Oculus Store if it didn't have MSAA. And that is why we're stuck with forward rendering instead of deferred rendering.
So forward rendering implies the use of a directional light. It's just coded in the shader, so use it. Also, stick to 1 shadow casting light and 2 secondary lights. You can have more, but make sure that you are only seeing 3 at any given time.
And fake it or bake it. In so many cases, you don't actually need real-time lights. You can bake things and things will get way, way, way more optimized. You'll be seeing everything run faster. And be aggressive and preemptive with your lighting layers and planning and managing them right from the beginning, because any optimizing you do, the engine doesn't have to. So that's good.
So we're going to go over some shadow tricks that we've used to get as much performance that we could out of a high-end experience. The first one is shadow cube maps. This is a shadowing technique developed by ARM. It's designed for high-end mobile, but we just ported it to VR. By storing occluding scene geometry in an alpha cube map, which is a lot like a reflection probe, you can make lights move around and cast shadows in a static scene. It's cheap and really powerful. We also use shadow proxies, so for our animated characters that we're using multiple materials and we're extremely high detailed with their geometry, we would use their lowest level of detail model where it looks like a PlayStation 1 character. We'd use that to cast shadows instead. This reduces the draw calls, the complexity, and if you're softening your shadows, you can't tell a difference.
So Blub shadows are extremely, extremely useful. They're super cheap, and they can look really good up close. They're nice, free, soft shadows. So in any case where you can use them, make sure to at least try it.
One technique we developed on the team is called bake dynamic shadows. We designed this to handle casting shadows in really, really complex scenes. Like one time we had a building exploding, so there are bricks and shrapnel flying everywhere, and we wanted to cast shadows. So if you can guarantee an animation and a light source ahead of time, you can record the shadow it casts onto a texture. In each pixel, you record 2 time ranges. So with the red and the green and the blue and the alpha, you record times of when there's a shadow casting and when there's not. With a single 1024 by 1024 texture, you can actually shadow an entire room for about 8 seconds. And as it's been pre-computed and projected ahead of time, this is just a single world space texture lookup. It's extremely fast.
So image effects are a huge part of making CG look great. Unfortunately, they are super expensive. You can't just throw them on the camera at the end, so make sure you throw them on the camera at the beginning.
Yeah, and make sure that every effect you want, you do in one pass. Every time you have to wait for the screen to resolve again is a huge time sink. For more reflective assets, you should make a unique reflection probe for each and hand tune it for the angles that it can be viewed at, which is probably infinite in VR. Box reflection probes are not required for distant objects.
Just keep in mind. And definitely, like it says here, don't use the default reflection probe settings. Those are set to be optimal for other things and skyboxes, and for VR, this is going to really hurt your performance.
So this is an example of a box reflection done right. Even in VR, when we would stick our heads against the glass, the reflection, the illusion never broke.
If you look closely, you can see the reflection of the room in there. That's kind of the point of this. Yeah, I see it. So we're going to talk a bit about input and interaction. A lot of this will kind of fall out of the scope of this talk, but when it comes to kind of turning it up to 11, you should make sure that everything the user can reach has a one-to-one reaction. Basically what that means is that the hand, where the user's hand is the authority, not you as the designer. And the mapping of the spatial device is actually, to its virtual counterpoint, is actually non-obvious for abstract representation or even hands. Test what feels right, not what seems best. So if you think, okay, well, a good example is if you have a scene where there's an actual Vive or Oculus controller and a hand holding it, if you map exactly where your hand is spatially to where it is in the virtual world, it actually doesn't feel right. You've got to kind of put it somewhere in between to have the articulation actually feel natural.
A big cause for this is the weight of the controllers, whether it's the Vive or the Oculus. And the Vive is a wand, so you're going to actually have weight above your hand. This causes a weird disparity. With Oculus, it feels like my hands are made out of clay, unless I actually give my hand models a reason to be heavy, like holding brass knuckles or having a big heavy glove. One trick you can do is actually position the hands further out or further up so that you get more motion for effort. This helps fight the disparity. Yeah, so this is an example of immediacy. If you're detecting a punch, the target should match the hand without any kind of lerping. It won't look as good as a smooth animation system, but if you try to animate it, no matter what speed you go at, it feels laggy and weird. You can use physics or snapped poses. There wasn't any animation speed that felt good. This goes for any kind of data you're calculating for input too. So if you're calculating hand speed or trying to do a whoosh and you're trying to smooth the velocity, you actually need to extrapolate. You need to make your smoothing immediate as well.
So now we're going to talk a bit about 3D audio.
So HRTF, or head-related transfer function, simulates the shape and position of your ears for spatial and positional audio. Yeah,
basically, for anyone who hasn't really looked too much into this, spatialized audio is just sort of it's sound based on how far you are away from an object. So if I have a sound source here and the object moves away or I move away from the sound source, it'll get quieter. But if I actually have an HRTF system, as I turn my head, I'll hear different levels of sound in each of my ears. So, here we go.
So consider the following scene. A player standing in an office building. A giant monster outside lets out a tremendous roar. The low guttural sounds hit the player in the chest. It shakes the foundations in the pipe. It rocks the lights and vibrates anything that's not nailed down. A high-pitched screech is bouncing off all the surfaces. Is that just distance and direction? It's not. So we do have some hardware that can do some of these things now. We have like subpacks that can pound you in the chest. There's like devices that will blow air at you in VR. But you still have to have your designer then model out not just what you can see, but an entire environment. Mm-hmm. We have a long way to go.
And there's a couple of things here that I didn't mention. The mix iterative thing, just like the animation, you want to make sure that a sound designer will provide a sound or a voice recording or something and say, okay, this is perfect, this is exactly what you wanted. But if you get it into VR and it doesn't sound perfect, you've either got to change your settings in there or get them to mix it again. And just like for the other things, avoid the default fall-offs. And there is the opportunity with audio too to bake. If you know the exact circumstances that an audio clip is going to play, feel free to say, okay, this thing's this far away from, they're only a foot apart and they're 10 feet away from you. Why not make them the same emitter? If you know the reverb conditions, in some cases you can bake that in, not for voice. So spatialized audio is super expensive, so this is definitely something that you want to optimize as much as possible. So we got we kind of work closely with a VR audio guy, and we got some tips for him on doing voice recordings. And unlike doing traditional voice recordings for video games where you get that up close, SMR kind of voice recordings, that's actually what it sounds like if you take it into VR and play it back just like that. Really kind of what you have to do is actually use techniques that are kind of frowned upon if you're doing voiceovers for film or for games, and that's step back from the person who's doing the voiceover, capture some of the room, use a boom mic and have some atmosphere in it. So we also wanted to, today, because it's a really broad topic, we wanted to leave a bunch of time for questions and talk about whatever you guys want to talk about, and any of these optimization techniques that you see right here. By the way, these slides will be available, so you can come back to this stuff and go through it at your will. And of course, get in touch with us. So, do we have any mics set up, or is there a good way for anybody to ask questions?
What about cookies? Like, when it comes to VR and cookies and the lighting, how would you work that in?
So shadow cube maps are essentially a 360-degree cookie. Mm-hmm. So the answer is yes.
You can work it in, yeah. It works fine. Mm-hmm. Question? Jana? Yeah. PSVR, yeah. Sorry,
I'm just wondering, as far as the status of PSVR and how that fits within Unity 5, 5.4, and kind of unifying the builds and all that stuff.
I mean, ideally we'll be targeting every platform as it becomes available. So yes, PSVR we're actively working on integrating PSVR. Yeah. Not working?
Hello?
Hi.
Hi. I was wondering about PVR shaders and if it's better to develop them in your like Maya or Max or something like that, or is it better to develop them in Unity?
I would recommend developing them in Unity. There are going to be differences between the software. Everybody tries to get things to be consistent, but that's not always the case. If you develop it in Unity, what you see is what you're going to get.
I got a couple of questions. Could you talk a little bit about, we're running into a lot of aliasing issues, and even if we turn on anti-aliasing inside the project settings and stuff, we still are fighting with it. And you talked about batching. Is there what kind of settings, or is it more of preparing your objects with the correct materials and stuff?
So for batching, there are a lot of pretty basic rules. You make sure that any objects that aren't moving are set to static. This will make them available to the batching system. You also make sure they're using the same material. So if you start atlasing your textures, you will get a lot of objects batching together. Those are the kind of high-level ways to get good batching results. In terms of anti-aliasing, just turning on MSAA is only going to smooth out the polygonal edges. Anything inside has to be done through bilinear filtering of your textures, but that's still going to fail for textures that do more kind of intense functions like high specular highlights. In that case, you might just want to cut them.
And there's a lot you can do, like batching and stuff, but really not every technique is appropriate for every situation, which is why it's so important to test and profile things that you're like, oh yeah, this button is supposed to speed things up, but based on your current setup, it actually might be slowing things down, so you definitely.
Thanks, guys.
Yeah.
This is on?
Hi.
How many of the NVIDIA Maxwell and Pascal optimizations are currently supported by Unity, like multi-res and SLI and the various VR works?
Currently implemented and available right now in 5.4 is basically the, we might not be the right guys to answer that, seeing as we're kind of all over the place using alpha versions of Unity, but can you speak to that?
I can't say for release version because we live in alpha and beta, so we do have access to a lot of these things, and I want to give an honest answer.
So yeah, we can get in touch with us. We can look into that for you.
I have a question. I'm trying to work with photogrammetry and have performances of actors as sprites kind of outside the chaperone walls, so you don't see that they don't have volume, but basically they'd be cardboard cutouts and their performances are sprites, and then the environments are real world environments that have been surveyed with photogrammetry, and I wondered if you had any thoughts about that type of scenario.
So we've done photogrammetry scenes before without actors, but just putting it into Unity. Lighting is a lot different with photogrammetry because even the perfect capture is going to have some lighting data built in. You should check out Valve's Lab Renderer. They actually have photogrammetry specific shaders, which will help with a lot of these things. They can apply additional lights while not interfering with what already exists.
Hi. First off, thanks for coming out and speaking to us and stuff. The question is a bit more of a design-oriented question, but from your experience, from whatever you've seen, whatever you've worked with, do you have any tips for integrating UI well to VR projects?
Definitely, yeah. So integrating existing flat 2D UIs or making new things?
Making new ones.
Yeah. So the first thing I would say there is if you at all can, I mean, this would be dependent on the experience, but if you at all can, try not to use flat UI systems with VR. With these controllers, we have bimanual coordination, meaning we can use two hands to work on the same thing, like things like tying a shoelace or pulling the cork out of a bottle. We have gestures. We have interacting with 3D objects, and so I find for myself a good design starting point when trying to create UI elements in VR is to just right off the bat say, I'm not going to use flat 2D elements. And as long as everything is reactive, going back to what we talked about before, where I kind of get, I get near something or I hover my controller over something and there is a reaction, people will learn your system really, really fast. Yeah, so there's ideas I've been exploring recently where instead of just using, just one pointer on a controller, using the back of the controller for something, using the middle of the controller for something, doing different things when the controllers are out of view of the HMD, doing different things when they're out to the sides, when they're together, when they're reversed. The possibilities are endless. We don't really, it's rare that there will be a good reason to use a flat 2D UI in VR.
I'd say the one exception to that is text, because you're going to want to display words to people. In that case, you can use a canvas. You can make it render in world space, and it'll just be in 3D space. It looks fine in VR.
questions. One is, have you worked with depth kit and RGBD video at all? And do you have a sense of how expensive that is? Sort of like animated point cloud. And then the other is, where can you suggest a place to look to hire Unity devs to work on nonfiction work?
You know what?
So I have worked with one point cloud system in Unity for video, and that was 8i. And that requires a pretty decent rig, but they're actively working on optimizing it down for mobile.
So yeah, if you haven't heard, have you heard of 8i? I highly recommend. Yeah, 8 little I. Yeah. And when it comes to hiring Unity devs, might be on your own there. Yeah. They're yeah, it's a pretty good market for anyone right now who's talented in Unity looking for a job. And were you thinking in VR or just in general? Yeah, yeah. There's yeah, you might be in a fight there. What's that? Actually, Unity user meetup groups. I don't know if you've been going to any of those, but I spoke on one here in LA on Thursday. There was a great turnout, and I was really surprised at how many people that were there who were actually at least intermediate users of Unity.
I was curious if you could talk more about mobile optimizations, especially when it comes to using things like Playmaker Choreographer for audio, and if that's a wise thing to do or to be avoided at all costs.
Nope, not at all. I mean, that would be a kind of a consideration you would have right off the bat. Things like visual scripting systems will always have a bit of a higher overhead than just hard coding everything. But if you establish that right off the bat, get a good idea for how much how much you're going to lose there in terms of performance, and then just build around that. A lot of everything we've talked about today applies to mobile as well. So all these optimizations are perfectly valid.
That's one of the keys with VR is that because the platform is so demanding that if you kind of take a high-end mobile approach and just make it really extreme, that's good for desktop.
Here and here, yeah. Yeah, go ahead, sir.
You mentioned trying to speed up the iteration process in content creation apps, or like going straight to VR headsets. Is that something that you guys are working on, or third-party devs are tackling?
Both.
Both. Yep. There's already a Maya plugin for viewing things in VR and stuff, but actually, I don't know if you've ever heard of Editor VR. So Unity is actually actively working on the tools to not necessarily create content in the sense that like a 3D modeling or 3D sculpting or animation program would do, although I shouldn't say that. Editor VR will be a great tool for you or anyone to really be able to work and do and get past a lot of the iterative problems we brought up earlier in VR. Yeah.
I was just wondering, have you guys been messing at all with like teleportation or just movement systems in VR other than teleportation? Because that's kind of been the staple, at least the safe to go with. I mean, we've kind of tested walking and trying to simulate that to move around, but there's still like a sickness that comes from it. I've seen some things like potentially leaning would be like a way to like kind of fake it, or have you guys done anything like that?
It's funny you should mention that. This last Thursday, we did a talk on that very subject. We'll get those slides online too. We've explored a couple different methods. We've explored the leaning method. We've done, motion amplification. We've done cube lifts. We've done the big portal sphere that you have to walk around to go inside. We have bigger lists like penguin walking and all sorts of things like that. Yeah, we'll get those slides online too.
Oh, yeah.
What are the pros and cons of using the lab render, and are any of those features going to be standardized in Unity 5.4 in the future?
So some of the optimizations of the lab render, like having a shared shadow map, those are already in Unity. The lab render only works on Steam VR, so it will work with Oculus if you're running your Oculus through Steam VR. It's not going to go back to mobile. But otherwise, it gives you 18 lights. It gives you adaptive quality. It gives you a lot of advantages. The way I describe it is that if you hand tune your VR experience, you can to get 100% of the effort, 100% of the graphical quality. The lab render will give you maybe 90 or 95% of it for basically no work.
And I think in the future we'll see other kind of like different types of render loops being developed by other companies that'll be available for specific situations. The lab render is great. It's not perfect for absolutely everything, but nothing is.
So this is a question from a director's viewpoint. Very happy with all the 2D suites of Premiere and Avid, etc. And that's my modality for storytelling. Is there a recommendation you guys would have, maybe a kind of middleware or a simplified interface for a filmmaker coming to Unity? Is there an add-on, a plug-in, a simplified interface that would allow me to do quick moves, quick visualizations, and then turn that over to my Unity developer, for instance?
There definitely are third-party tools on the asset store that'll help. There hasn't been a great focus so far for using Unity to develop for film. It definitely is useful for that. But if you get in touch with me after this, I can connect you with some people who will definitely be able to help you out in that regard.
Cool, and it would also directly apply to VR development as well.
Mm-hmm. And I think using the editor VR tool that Unity is actively developing will definitely be great for quickly setting up, visualizations. There's a tool called Tvori that I think was just released, TVORI, which is actually a VR tool specifically for cinematic visualizations. But we had a question over there.
Yeah, over here on your right. Yeah, just kind of like steering back into the technical noodling for a second. Could you give me some recommendations for optimizing screen space ambient occlusion, baking versus live? Because that seems to be eluding me at the moment.
Like baking ambient occlusion versus using screen space?
Yeah, and settings for screen space that you would recommend in a fairly close-up setting, especially with things like characters.
So for our projects when we were working on these, the single pass stereo pipeline for effects hadn't been in place yet, so we actually actively avoided any kind of image effect. I don't have concrete numbers for you in that yet. So we ended up baking all of our ambient occlusion, and we ended up relying pretty heavily on the real-time GI system.
Do you have any recommendations for object pooling, as in spawning a lot of objects and something expensive as fractals for mobile VR?
There are definitely some really, I think Pool Manager on the Asset Store is a really good pooling solution. So that's kind of something that's been kind of tackled pretty effectively by the Unity community and by publishers on the Asset Store. So I definitely recommend checking out something called Pool Manager. And if that doesn't work for you, under the pooling tag on the Asset Store, there'll definitely be there'll be some good options. And it's super useful for mobile or, of course, in this case, VR.
Another thing you should try is actually turning off culling and see if it runs faster. If a scene is really complex, sometimes it's better not to cull at all.
And that was the last question? Okay, thank you very much.